Okay, we're here with Rita to talk about representing proportional relationships. You ready to go?
Yeah.
Okay, so we're going to talk about it in two ways. One way is to think about graphs, tables, and equations, which are all different ways to represent the same thing, this idea of a proportional relationship. Okay?
Okay.
And then we'll talk about how that's used in the real world. Okay, so let's first talk about graphs, tables, and equations. So let's look at a situation here. What we're going to do is we're always going to want to have this goal. Write an equation to represent the proportional relationship. And the equation will always be in the form, and this is really important, it'll always be in the form y equals k times x. So that k is just some number. It's a constant. That's often used in math, the letter k for constant. So it's not a variable like we think of y and x. It's going to stay the same. So it might be y equals 3x, or it might be y equals negative 2 million x, or something. It's always just a number. Okay?
Okay.
All right, so let's go ahead and look at a table first. So in this table, we have some x values and some y values, and we're going to ask ourselves, what is that number k? Now that number k is the constant of proportionality. It's the one that always multiplies by x to get y. So any ideas what it is in this table?
Yeah, I think it is 2.
Good. And how did you get to 2 so quickly? Did you look at this row right here?
Yeah, I looked at x equals 1.
Yeah, and that's always a good place to start. If it's there in your table, because you know that 1 times k is going to be k, and so you can see that the constant proportionality is just going to be 2 here. And you can test our thinking. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, 4 times 2 is 8, etc. So we know that that number that we're multiplying x by to get y is 2. And so we know that that's the constant of proportionality. Now, we can also graph this. So let's go ahead and look at what the graph would look like. And this is really interesting too, because what we have, you can see, is those same points that are in the table. They're all labeled here, just like the table values. And what shape does this graph make? Is it a curve, or how would you describe it?
That's a line.
It's a straight line, right? So these points are lining up in a straight line, and that's always true for a proportional relationship. And it's also always true that that line will go through the origin here, the point 0, 0. So that's one of the points in this relationship, just like we see here. Now, what we want to do is we want to write an equation y equals kx. And we know that k is what?
2.
2. So can you say what would be the equation that would describe this table and this graph then?
Y equals 2x.
Very good. And so that's what we were looking for here, okay? So you can represent this relationship between x and y in 3 different ways. You can represent it by a table, a graph, and maybe the most simple way, because it's the easiest to write, is by an equation, okay? Super useful for you. Now let's go look over at a real-world situation and see how we can use these things, okay?
Okay.
All right, so Areta works for a foundation that distributes rice to villages in Asia. She needs to distribute 1.2 tons of rice to each village. Okay, does that make sense so far?
Yeah.
Okay, now it asks us, write an equation to represent the proportional relationship between the number of villages, x, so x will be the number of villages, and the amount of rice, y. Okay, now at first it might seem confusing, but I'll give you a clue. It's going to be a very simple equation, still in this form y equals kx. So there's the number of villages x, and you're going to multiply that by some number in order to get the total amount of rice. So what would that number be?
Let's see. She distributes 1.2 tons of rice to each village. So 1.2.
Right, so let's just think it through. If there were one village, how many total tons would she have?
1.2.
Good. And if there were 2 villages, how many would she have?
2.4.
Good. So you're multiplying each time the number of villages times 1.2. So your instinct was right that it's y equals 1.2x is your equation, okay? So we're really just changing words here, a situation, into a very easy thing to write, a very short thing to write, I should say, which is the equation. And that becomes really useful for you in math. Of course, we can also graph this. We can go ahead and show that if she is going to be going to 1 village, as you say, she would need 1.2 tons of rice. 2 villages would be 2.4. We can go right up the line here and extend this forever. If there were 0 villages, she wouldn't need any rice, so that would be 0, 0. And you can see, just like we said, these points line up in a straight line that goes through the origin. Okay? So that's how you represent a proportional relationship with an equation. Make sense?
Yeah.
Good job.